Hey everybody. So today I just wanted to show you how to basically go about using your calculator to help answer questions like this one. So this was a question in my video I want you to watch. Um, that's also in this assignment where basically we're given some sort of really kind of messy looking x to the fourth problem. And this represents a model where X is the number of years since 1926, and f of X is the annual admissions to movies in the US in millions. So, a lot of times in real world problems, you're going to get these crazy kind of numbers, and like the methods that we've done so far with how to find like roots and different things like that can be kind of tough. So, I wanted to talk about basically how we can use our calculator to help us answer this. So, what I'm going to do first is I'm just going to go over to my like TI-84 kind of emulator thing here. And I'm going to type in that equation, which I'm going to move this. So we get negative point, negative, wait, I think I need to use this. Make sure you, I was about to use subtraction, which it's not like that. So negative 0.0017. That's not 100% great. X raised to the fourth, and then plus 31 x cubed, not divided by. And then minus 17.66 x squared, and then plus 277 x, and then plus 3005. And so make sure it's all typed in good. I think this one is. And then I just want to go ahead and graph this thing. And depending on your calculator, you could have all sorts of different kind of results here. Depends on like what windows you've used in the past and things like that. You have to know roughly a little bit about the shape of the graph in order to kind of make some sense of things. And we know that so this graph that we have right here is a negative x squared, x to the fourth. Sorry. So it's going to look, kind of like an upside down quadratic would sort of look, where it's going to shoot off to negative infinity when you go to both plus or minus infinity, like go to the left or right. So we're kind of seeing one of the spots where it shoots down, but we should see another one somewhere. So that means that we should change the window on this thing. And so if you think about the function a little bit, it's saying, we're only going to negative 10, which is honestly fine. But, this is the years part, the X values. And, we probably want more years than just 10 past 1920, what was it, 26? Yeah. So I might just put in like 100 years there or something like that. And then X scale here, probably do like maybe 10 for that. And then Y minimum, that's probably fine. This is millions of people. So, it doesn't make sense to go below zero, but having a few below zero is fine. And then Y max, the way I would think about that. So, we know that our y-intercept is 3005 based on this. So we've got to be at least probably more than 3005. I might do like 3100 as like a first attempt there. And then for the y scale, you can do like 100 or something. Don't worry about this kind of stuff down here, x-res and all that. So now if I just hit graph, you get that. So it's looking pretty good. We're missing some of the max over here. So I've got what was 3100. I might just add in my y max. I might add like 600 or something, just see what that looks like. Okay, so we're getting closer. I think I'm going to add even more this time. I'm going to do like 4,300. I think that should do it. Pretty good. Okay, so that's looking like a negative x to the fourth now a little bit. And I want to show you basically some buttons on your calculator that are going to help you find, the way I word it here is these, to find the value of all the turning points of the function. So any maximum and minimum for it. And so to do that on your calculator, you basically just go second trace here, which is calc. And then there's a bunch of really useful stuff in here, but these are the two, right, that we're going to use. So minimum and maximum are going to actually tell me, you're going to be able to do this thing on your calculator where it's going to literally tell you that turning point. So let's do minimum first, so just hit enter on that. And it should pop up with something kind of like this, where it's prompting you to find like left bound. And so you basically are like tracing on the curve now, and pretty self-explanatory, but basically you go to the left of like the minimum and you hit enter, and then you go to the right of the minimum, right bound question mark, and you hit enter. And then for guess, you can, if you want, go like closer to the minimum and guess like that. But honestly, the computer is pretty good in this thing, and you've basically given an interval, and what it's just gonna do is it's gonna check all the values in there, and it's just gonna tell you the lowest one. So just to show you, it doesn't need to be right there. I'm just gonna say, let's guess that's in the middle. But honestly, sometimes I'll do this for maximum. I just hit enter twice on the right bound to get the guess one kind of done. So you can see it just jumped. So now we know the minimum, this like turning point right here, is at 52.1696, blah, blah. And this is the y value of it. And then to do maximum, so go second, calc again, this trace thing. And then it's very similar. So to do a max, we just go over here. We got a maximum right there. We're going to do hit enter. That's a left bound. And then this is a right bound. And this time I'm just gonna, when it says guess, I'm just gonna hit enter again, and it just jumps you right to max. And so this is useful. So like in this question right here, when I said find the value of all the turning points, you could now do that, right? You could find the coordinate point that represents all the turning points. And then using that, you could basically sketch it a little bit better, because you could, go and plot points for the maximum and minimums, and then kind of connect it with a curve. And we talked about this one already when I went over the other video, but definitely it's not reasonable to think that this trend continues forever, because eventually it's going to go like down into the negatives. That doesn't make sense. People are still going to go to movies. But it's basically saying people go to less movies as time goes on, like that. Well, actually not forever. I guess for a little while it went up and up and up, and then it's been going down. And then it went up again. One more thing I wanted to show you. So if you do second trace, there was a thing in here called the zero. And the zero is another one that is useful for graphing these things. So zero is probably what you're thinking. It's going to help you find one of the zeros, one of the roots. And so, if you look at the y values between here and here, you can see I'm alternating between a negative and a positive right there. So somewhere in there, there's a zero, right? So if I go to the positive, that's a left bound, right? Positive y value. I hit enter, okay, and then it's going to say right bound. Go to a negative y value. It's like off the screen a little bit, but it's definitely, a right bound, because it's negative now, right of the root. And then guess, you can do the same thing. You just hit enter again. And so this is, I'm glad that it kind of did this. And a lot of times it'll actually give you zero, but sometimes students get this and they're a little confused. This is just the scientific notation stuff. So what they're basically saying is that at this x value, It's basically the root, because this is understood as -3 times 10 to the -9, which is a very small number, right? And so the e is just there for like trying to tell you exponent of, like, the exponent is -9. It's just like the shortcut way that the computer tells you it's a scientific notation. So if you see these kind of things, it's really, really, really close. I mean, that's a lot of zeros in front of this number. So um, that's kind of all I want to show you. Between the maximum, minimum, and zero thing, you should be able to do stuff like this now, where you can, well, sorry, like this one, where you can sketch a graph of the function.